Hey everybody, it's Moises here. I just want to welcome everybody to the new way that we're going to be doing labs for probably the rest of the semester. Just depends. Um, so what we're going to be doing today is talking about none other than asteroids. That's right. And as you can see on the bottom part of the screen, right there, lab activity on asteroids. We'll go ahead and we'll get started. Yeah, shall we? So here are the slides. So we'll go ahead and get started with here, the purpose. In this lab, the student will learn about asteroids, their characteristics, compositions, and motion. The student will be introduced to techniques that astronomers use to discover asteroids and to measure their coordinates in the sky. The students will learn how to obtain Ephemeris for MPC and will be provided with real data in which they will be able to identify an asteroid and then obtain information about it. So it's pretty cool. And just as the purpose says, you will be looking at a real asteroid and you'll get some real information off of that. So a little bit of background. Asteroids, sometimes called minor planets, are rocky, airless remnants left over from early formation of our solar system about 4.6 billion years ago. Then there we do include some images here of some asteroids. The current known asteroid count is over 800,000. Over 800,000, and most of them can be found orbiting the Sun between Mars and Jupiter within the main asteroid belt. Asteroids range in size from Vesta, the largest at about 329 miles or 530 kilometers in diameter, to bodies that are less than 33 feet or 10 meters across. Asteroids come in a variety of shapes and sizes. Some are solid bodies, while others are small piles of rubber bound together by gravity. One is even known to have its own set of rings. It's pretty cool. I had an opportunity to actually learn how to do observation from the guy that did the observation in this discovery. It's really cool. It's really neat. Now, there are more than 150 asteroids that are known to have a small companion moon, and some having two moons. Binary or double asteroids also exist, in which two asteroids of roughly equal size orbit each other, and triple asteroid systems are known as well. And so here are some images from the Arecibo Observatory. If you remember from the telescopes lab, the Arecibo telescope is a radio telescope, and it's really big. It sits in a sinkhole in Puerto Rico, and this is really cool. Now, composition. There are several possible ways of grouping asteroids. Astronomers use schemes of varying complexities based on composition, orbit characteristics, or combination of both. The simplest way puts them into three basic categories based on their composition: C, S, and M types. C, S, and M types. The C type is chondrite asteroids are most common, right? C type, most common. That's something you should keep in your head. C type are most common, right? Probably consist of clay and silicate rocks and are dark in appearance. They are among the most ancient objects in the solar system. The S type, or stony, are made of silicate materials and nickel iron. So for this one, the S type, which S type for stony, you can think of, or the way that I remember this one is for the silicate materials, right? There is nickel iron, but you'll notice, right, the M type. The M type is the metallic type, and this contains nickel iron as well. So between the S type and the M type, the way that I remember the S type is the silicate materials is the key part for this. So C type, common, right? So C type is good. Then the S type. S type are for the silicate materials, right? So S type, and now it's your turn to say it, silicate. So cool. And the M type are metallic. All right, so C-type common or most common, S-type silicate materials, and the M-types are metallic. And the asteroids' compositional differences are related to how far from the sun they formed. Some experienced high temperatures after they formed and partly melted, with iron sinking to the center and forcing basaltic or volcanic lava to surface, or to the surface. Right. Classifications. Main asteroid belt. The majority of known asteroids orbit within the asteroid belt between Mars and Jupiter, generally with not very elongated orbits. Is estimated to contain between 1.1 and 1.9 million asteroids larger than 1 kilometer or 0.6 miles in diameter. So now this number is an estimate, right, based on surveys that have already been done, and it says here between 1.1 and 1.9 million asteroids larger than a kilometer. That does not include those that are less than a kilometer. So we have these types that are called Trojans. Trojans, these asteroids share an orbit with a larger planet, but do not collide with it because they gather around two special places in the orbit. These places are called the L4 and L5 Lagrangian points. There, the gravitational pull from the sun and the planet are balanced by the Trojans' tendencies to otherwise fly out of orbit. So they're pretty much stuck in orbit within these L4 and L5 Lagrangian points. The near-Earth asteroids. These objects have orbits that pass close by Earth. Asteroids that actually cross Earth's paths or Earth's orbital path are known as Earth crossers. As of June 19, 2013, 10,003 near-Earth asteroids are known, and the number over 1 kilometer in diameter is thought to be 861, and there are 1,409 classified as potentially hazardous. Right, so these are those that in simulations they'll check Earth's orbit and see if there's any time that Earth and the asteroid's orbit first cross, so they'll be known as Earth crossers, but also if there's any chance that they'll get close to Earth, right? It's really something that's really special right now is that in April there will be a close approach to, and one of the most closest approach of asteroids that I've heard of in recent times. And if I'm not mistaken, I might be wrong, so you have to look it up, Google it, or search it online, whichever search engine you use. The asteroid is set to have a closest approach in April, and if I'm not mistaken, the distance to Earth is actually less than that of the Moon. So when we're talking about objects that are a distance away from Earth, then that is that's pretty close. That's pretty close. So we keep a close eye on those. Now, the orbits. The asteroids are orbiting the sun, each one traveling around the sun fast enough for orbits not to degrade. If something slows an asteroid, it may fall towards the sun, towards Mars, or towards Jupiter, right? In order to determine the unknown orbit of a body as an asteroid, some observations of its motion with time are required. In early modern astronomy, the only available observational data for celestial objects were right ascension and declination, right? And right ascension and declination are the coordinate system, or the coordinates that we use, right, on the celestial globe. The orbit determination must take into account that the apparent celestial motion of the body is influenced by the observer's own motion. For instance, an observer on Earth tracking an asteroid must take into account the motion of Earth around the sun, the rotation of the Earth, and the observer's local latitude and longitude, as these affect the apparent position of the body. Even if no distance information is available, the orbit can still be determined if 3 or more observations of the body's right ascension and declination have been made. Now, here is something that's really cool. It's called the MPC. The MPC is the Minor Planet Center. And the Minor Planet Center is the official worldwide organization in charge of collecting observational data for minor planets, such as asteroids and comets, calculating their orbits and publishing this information. Now, the key word here is that it's a worldwide organization. So all this is a big collaboration across all major countries that have space programs, including the US, Russia, China. We all pitch in to publishing and finding this information. Why? It's a matter of security, right? It's in the best interest for humanity to keep track of these the asteroids, especially if we're talking about potentially hazardous objects. So the MPC is also responsible for the designation of minor planets, comets, and natural satellites in the solar system. The Minor Planet Center hosts an ephemeris generator that produces ephemerides. In astronomy and celestial navigation, an ephemeris, plural ephemerides, provides the trajectory of naturally occurring astronomical objects as well as artificial satellites in the sky. In other words, the position and possibly velocity over time. So this is a new word, so I suggest that you practice it. So I'll say it and then you say it. Ready? Ephemeris. All right, one more time. Ephemeris. Cool. Now, threat to life on Earth. Approximately 65 million years ago, a mass extinction occurred on planet Earth caused by an asteroid estimated to be between 7 and 50 miles, or 11 and 51 kilometers wide, that completely wiped out the dinosaurs through a mass-scale global climate disruption. All right. And it's pretty important why you would see that the Minor Planet Center functions and people contribute. So one of the things that we do at the observatory is we are interested in actually tracking these objects. So what we'll do is we'll head out to the observatory and make a plan and track these objects from the Minor Planet Center. So in the lab activity for asteroids, you'll be using some tools that will allow you to see what are objects that are currently visible in your local night sky, as well as then getting the ephemeris or ephemerides for those different objects through the Minor Planet Center website. So that's something that's really cool. That's a process that we as well follow, getting the ephemerides from the Minor Planet Center. And the last thing is that you could actually submit your findings to the Minor Planet Center as citizen scientists. So if for any of those at home that may want to try getting their own telescope out and setting up, it'll be important that you find the exact GPS coordinates of your location. As we said in one of the earlier slides, right? The orbit calculation depends on your position as well as the position of right ascension declination of the object. But with just very few tools, you too can also participate in getting this data. So we're gonna try something really awesome. And of course, if you have any questions, make sure that you reach out and have a great day.